Alternator Man here. I want to talk to you about exciting, self-exciting alternators. Now that may sound funny to you if you know anything about it, because self-exciting alternators mean that they start themselves up. In other words, all you have to do is hook up your battery wire either here, here, or here, and that's all. There's no ignition wire to the alternator at all to activate it, and it just, when it starts spinning, it excites itself. I want to know how that does that. This is the innards of a 10SI alternator all bolted together. You have your stator and you have your rotor, and both your stator and rotor are electromagnets. The rotor gets its power through the brushes and the brush holder, and the stator gets its power through the battery post on the back of the alternator. It has diodes in it. Diodes are one-way gates. They let power flow out but nothing flow back in, but they do let a very, very minute amount of power back into the stator, keeping its magnetism really low but somewhat there. The rotor basically has no magnetism till the brushes fire it, other than residual magnetism. Basically, self-exciting units work off the residual magnetism left over in the stator and the rotor. The rotor, once this gets powered to it, if you've ever made an electromagnet out of a battery and a nail, once you send power through that battery, through the wire to the nail, when you're done with the battery and you shut it off, that nail still has a little bit of magnetism left over, and that's how these are. And what it does, and all the voltage, self-exciting voltage regulator would be right here, and typically you'd have an ignition wire to activate it, but on self-exciting you don't have anything there. And so what it is, when a rotor spins inside the stator, a little signal goes up through the stator, through the diode tree on the 10SI series, up and gets to the voltage regulator. The voltage regulator sees that minute pulse of power, and it knows then to turn itself on. So the regulator turns itself on, and away the whole system goes. And the reason I'm talking about is I got a call from a guy who has he got a CS144 alternator, self-exciting, and it sat around for about a year on a shelf, and he stuck it on a vehicle and tried it, and it didn't work. And he called and says, "What's going on?" So what it is, and the reason it didn't work, is because this maintains its magnetism because power is connected to the battery post, and that little bit of leakage through into the stator kind of keeps the stator alive, and the rotor is going to have a little bit. But when it sits on a shelf and it's not connected to the battery, it hasn't been used, it ends up losing all of that magnetism to the point where you hook it up and it starts spinning, it won't do anything. So therefore you have to excite them. Now there's a lot of manufacturers that are involved in self-exciting. You've got your GM alternators, the CS series, the CS130, CS144, the CS130D. This is the SI series. Denso has one, Ford has one, but they all excite and do the same exact thing. So what you have to do, if your self-exciting alternator has been sitting around or it just isn't working, you have to excite them. So this is how you excite them. On the earlier SI series, it has this black plastic plug on it. You pry that plug off, and what you'd want to do is run a jumper from your main battery with the alternator hooked up and running. Run a main jumper from your battery post to your R or number 1 terminal, and just momentarily touch it on there until it gets going. And once it gets going and makes magnetism, then it's going to be good for quite a while. It's going to hold on to that residual magnetism. With all the GM CS series, this is CS130. It covers the 130D, which is a 4-pin, but it's rounded end. It's got this plug-in right here. You have little bitty letters. It says SFLP on these little letters. What the P is a pulse for a tachometer. Some GM vehicles and other manufacturer vehicles can run their tachometer from a pulse on the alternator, and that's actually coming from the stator lead inside the alternator. They're actually getting that pulse from one of these stator leads. So you have to be kind of careful on these because this is AC current. So with this alternator hooked up and running, what you'd want to do is take a small jumper wire, and go in there and just touch that P terminal, which is going to send 12-volt power directly into the stator. Well, once that thing gets going, you have to be careful because AC power will come out of that stator. So you want to use a fully insulated probe to get in there and just touch it on that and see if that does the job. That will power up the stator and get it all magnetized for you. And once they get going, as I said, once they get going, they should hold their magnetism for quite a long time. Now we end up with a 10SI. A lot of people put these on tractors and things like that, where they won't excite. You may have to end up, the SI series will still work off of an ignition wire. The CS series won't. All the CS series, they kick on right away. If you start a CS series, it's going to power up and give you power immediately. Sometimes the SI series, you have to rev them, and sometimes they'll turn so slow on the motor that they won't activate. And in that case, you're going to have to either set up a key switch and touch it here, or you can do a push button. You can put a push button on your dash or wherever, and if your alternator does not want to kick on your self-exciter, you can just pulse it, where a regular alternator has to have an ignition wire to it at all times. And so if you just pulse that, if you just touch that with a self-exciting, it will take off, it'll spark a little bit, but it'll take off and it'll go and it'll stay. If it's a non-self-exciting alternator, when you touch that on or take it off, it will quit. It'll run with it on, but then when it's off, it'll quit. That's a non-self-exciting type regulator. That's one way to tell. When you get into the 6-volt alternators, a lot of people are converting generators to 6-volt alternators. Now when the negative ground 6 volts are going to excite the same way from the battery post to the number 1 terminal, but with the 6-volt positive ground, everything is reversed, but the voltage regulators in the positive ground are still negative ground. To excite a positive ground 10SI type alternator, you have to run from the case to the number 1 terminal, because in positive ground, negative goes to the battery post right here, and positive actually goes to the case. But the regulators are still set up for negative ground. So this, with a negative ground setup, you have to put positive power to the number 1 terminal. So with a positive ground setup, you have to run from the case to the number 1 terminal. You're still doing positive ground to that terminal. And that is why, in some cases, you would have to excite a self-exciting alternator. It sounds kind of weird. A lot of people don't think, why would I have to excite a self-exciting alternator? But as I said, they can lose their residual magnetism from sitting around, whatever. All kinds of things can take out the magnetism. You'll get them started and they just won't work. But once you get them started, they should go all the time.